Okay, so let's look at now a particular type of equation, a linear equation. That's the equation we have of this type. So we have ax plus b equal to 0. These types of equation can arise in many different situations. For example, let's take an example of an equation. (6x plus 3 and 3x minus 9. So let's say we want to solve this equation. Is this a linear equation? Okay, it doesn't look like this exactly, but you can easily re-express this one as a linear equation. So let's now first rewrite it a little bit to see that it is a linear equation. Since it's an equation, we want now to create equivalent equations. Okay, so we can add or subtract the same number on both sides. For example, we can subtract 3 on both sides. Oh, so we can add 9 on both sides. Let's do that instead. So we add 9 on both sides. Then we have created an equivalent equation according to what we had said previously. This one can be simplified, and simplifying an equation is of course giving an equivalent equation. So if I have equation, just simplify it, and of course the solutions doesn't change. So I have a new equivalent. You see the reason I added 9 because we get rid of this one. And now I can continue. I could subtract 3x on both sides. That will also create an equivalent equation because I can subtract any number. And simplifying that will give us 3x, because 6x minus 3x is 3x plus 12. And this will be 0 on the right hand side. So now we see that this equation is equivalent to a linear equation. So therefore we consider this also to be a linear equation. Okay, so how can you solve this equation? Here we see that if we can transform this to an equivalent equation, that is obvious how to solve. So let us subtract on both sides 12, and the effect of that will be that it looks like that has been moved over with the change of sign. But what we're actually doing is things like this. We add the same number on both sides, or we subtract the same number on both sides. But the effect will be like it's just moved over. But it's important to remember when we say just move over, we don't really want move over. That's just a memory rule. What really happening is that we add the same on both sides or subtract on both on the same side. So here we would have subtracted 12 on both sides, and the effect would be this. Now we can divide both sides with the same number. And that will create an equivalent equation. This here, it can be simplified because we can simplify this fraction. This will be simplified to x. And this will be minus 4. So this is equivalent to this one. And now we see we have got an equation, this extremely simple equation that is obvious, has the only solution x equal to minus 4. Because if I put x equal to minus 4 here, then this is really true. That means that original equation, this one, the only solution to that one is this. So we know that minus 4 is a solution to this, and that it's the only solution to this. So this is the way to go when to solve linear equations. So linear equations are of this type. So let's take another example. Let's say that we have a car, and it moves with a constant speed of 10 meters per second. Okay, so how far will it have moved in a certain time? That is given by physics according to this formula. So in the time t, it will given it have moved this far, meaning that it has moved 10 times t. Okay, so how long time does it take before it has moved, let's say 120 meters, if you started at 0? And then it's obvious what we should do. We should plug in 120 in the distance, and then we should solve for t. Okay, so we should solve this equation, this linear equation. Solve this, we can solve it algebraically. And in the previous example, we solved things algebraically. Let's now solve it algebraically also. Okay, so we make an equivalent equation. So now I don't write out this equivalent sign all the time. So just make it implicit. So I divide both sides by 10. And this is 12. This is t. Or you can just as well write it as t equals 12. So after 12 seconds, it has reached 120 meters. Okay, it wasn't very difficult to guess this solution to this problem. But the point here is that we have now solved the equation algebraically. So we have solved this equation algebraically. However, one can also solve it using a graph. Graphically, you can solve it. So let's see how to do that. Because now here, what did we have here? Here was the function. So here we had the distance it moved, and here we have time. And what is this? This is a straight line because it's a linear function. Okay, so here we have a linear function, and it starts in 0 because there is no m value. You see there's no m constant here, meaning that it will cross the y-axis in the 0. So this will be a straight line, and the slope will be 10, meaning if we go 1 second, we'll go a distance up for 10. So we increase 10 if you go one distance 1 here. Okay, so let's say that we want to find out now how long does it take before we reach 120 meters. What does that mean? That means that if you put 120 here and make a horizontal line, so here is 120 meters, then we want to know when does this cross this line. So what is the time it takes for these two to cross? Okay, so that's called to solve it graphically. So in this case, I just have to read off from my figure. So if I have drawn these lines carefully, then I will have 1, 2, 3, and then I actually see that here I will have 12. Jumping ahead a little bit there. So I can just read off. If I read off, okay, I find the point where they cross, and then I go down here. Then I can just read off my graph that this happens, the cross after 12 seconds. So I know that the solution to this equation is 12. And that I found by solving it graphically. The problem is to solve it graphically. You can't never draw a figure accurate enough so you can solve it perfectly just using a figure. So this will only give you approximate solutions to draw a figure. So solving an equation graphically will in general just give you approximate solutions. If you want exact solution, you should do it algebraically. So often it's preferable to do it algebraically.